in this talk I will focus more on the development. Because at the moment we don't just focus on tap-rooted free crops creating biopores, but we also include other deep-rooting crops with fibrous root systems. When we started this research with the subsoil, we focused on this larger cycle of exploring the deeper subsoil with the help of biopores as nutrients I explained yesterday. And our control free crop, which I presented yesterday, was called fescue, which has more root system which is intensively fibrous rooting and is active here in the topsoil and also in the upper subsoil layers. And in the beginning we did not even have this circle in mind, so we thought we would compare a tap-rooted free crop system like a subsoil oriented system with a topsoil oriented system, but with the years we found that this is not the whole story. I presented the three crops yesterday. We had tap-rooted lucerne and chicory against fibrous-rooted fescue. And compared to other grasses that usually are used, like ryegrass, this has a very intensive root system. Because the session is focusing on nutrient uptake of deep-rooted crops, I also included the nutrient uptake of these free crops. And here we see that indeed the tap-rooted free crops, of course, especially lucerne, but also chicory, altogether have higher higher shoot dry matter in the 3 years of growth than tall fescue. Our design was that we had each crop 1 year, 2 year, 3 years. So we see here also the development that from 1 year to the 2 or 3 years, we always have an increase in shoot dry matter, which is especially pronounced for lucerne. And it's similar for nutrient uptakes. For nitrogen, of course, also we have a large dominance of lucerne. But if we compare chicory and fescue, we can also see that we have slightly more nitrogen in the chicory treatments as compared to the fescue treatments as a group. And this is more pronounced for phosphorus and potassium. I think chicory is also known as a phosphorus and potassium accumulating plant. And this we can see here. The lucerne we always leave a little bit out because it's a legume and we never know if the effects we generate are because of the nitrogen fixation or of the deep rooting. And so in the following talk I will also focus on these two treatments, which are non-legumes but still are differ in rooting depth and nutrient uptake. And what we were also interested in is the yield of the following crops, which is shown here, and we have several years and several trials, and I selected 3 years, which all focused on spring crops, as we found the effects on spring crops to be more pronounced than on winter crops. I showed yesterday the root development, and this picture of root development we found every year in all crops, no matter whether it was spring or winter. But with respect to the yield, the effects were stronger for the spring crops. And this is the first year after pre-cropping of our 3 trials. Trial A, 2010, Trial B, 2012, and Trial C, 2014 with almost identical design. And I focus on 2 years cropping of lucerne and chicory. And what we found is that yield is dependent on the interaction of these 3 crops and the weather conditions. And here we have 3 different weather conditions. The very first year of our research unit, we thought we had a dry year because there was a dry spell in June, and so we thought, oh great, so we will measure the effects of these biopores. And 2 years later, this was Yusan's year. We had a year with very abundant precipitation, both in the winter and during the vegetation period. But then again, 2 years later, we had a really dry year, and which was especially characterized by a dry winter. So starting in November, we had a negative water balance, which continued until June, and it was only in July that we had plenty of rain. Actually, now I know the site a little better, and this situation is quite normal. This is they frequently have dry spells in the spring or in the summer, and this is more unusual. What we found in this first year, there was no difference in yield between the pre-crop treatments. In 2012, we had a tendentially higher yield even after the fescue treatment. And in 2014, on a low level, we see that, of course, with the drought, yield decreased, but we had significantly higher yields after chicory. And then, yeah, we employed modeling. Within the research unit, there was a lot of modeling developed, both by Andrea Schnepp and Jülich on the 3D scale, small scale, to include biopores and soil structure in the models, because the models by that time that were available did not consider soil heterogeneity. And then we had another modeling group in Bonn, and they modeled on the field scale. And it took a long time actually, but by now, we see here 2019, we succeeded to couple these two models to try to model the effects of the precourse. We collected a lot of data, and so the first step was to reproduce the situation of 2010 and 2012. And the second step, Sabine used a weather generator to produce 100 scenarios, realistic scenarios of weather, and test the initial conditions of these 2 years with intermediate and high precipitation, and see how the precourse react. And what we can see as compared to the real data, that this effect was stronger. There was not much difference here, but here we had a significant effect then of higher yield after festival. And unfortunately, she did not include this year. And I always said this is missing, but then she said, oh, I've done so much work and this is so much data, I cannot include another year, sorry. But at the moment we're working on that, and really, with a similar approach, we're trying to include all years and all crops that we had, and also to consider better the initial conditions. This was quite nice because the things that I observed in the field more like empirically in 3 years, and the picture that I had, it's really the initial conditions that matter, and it's the winter. This was what she also found with modeling, that if she changed the initial conditions, there was a change, but during the vegetation period it was not so important what happened with the rain. And what was also interesting is that one focus on our research unit was always the nutrient acquisition from the subsoil, and it's very hard to quantify if we have nutrient uptake from which depths it comes. We did some labeling studies with biopores, but then still we only have the nitrogen uptake from biopores and not from the total subsoil. And in this modeling scenarios, she also gained some information on where the nutrients come from. And this was quite a surprise, because it is actually this scenario with the most favorable conditions that we had also the highest nutrient and water uptake from the subsoil. And this may seem surprising at first sight, but I think it is in line of what I presented yesterday of this pod experiment that Timo performed with the increasing number of biopores, that we also now know that if we have a good development of the root system, also what John presented, if we have a healthy root system and a strong root system, then of course this will also be able to